In this video, you'll learn how to create and run chaos experiment in Litmus and how do you configure probes inside of the chaos experiment in order to test the resilience of your system. So let's get started. Chaos experiments contain the series of chaos faults and probes in order to verify your resilience of your system or a service, whichever you're targeting. So let's create our first experiment. Let's name it FE kill, and we'll select the infra, then we'll go next. You can choose any of these. You can start with the blank canvas where you can create your own set of chaos scenario. You can also go with the templates which are in the chaos hub, which I just showed you. You can choose any of these. Upload your own YAML manifest if you have one. Now let's go to the blank canvas for this video, and let me add the fault to this. I'll be doing the simple pod delete experiment to test the resilience of the boutique app. So let me select pod delete, and then here we need to add the app kind as deployment, namespace is boutique, and we are targeting the front end app. Now next is you need to tune the fault. So you can change the chaos duration, and you can also add chaos intervals and everything. All these parameters you can change in order to modify or tune your fault. To know more about it, feel free to read our documentation to get more detailed understanding on what these are and how they can impact. This is the one that we created, and we can add it to the fault, and you can choose any of these modes. These are the modes which shows that how your probe should be executed. It can be start of the test, end of the test, or on the edge, continuous, or on chaos. So I'll go with the continuous. We want to just check if the front end service is up all the time whenever we perform chaos or not. So we'll apply the changes, and then we'll apply the changes, and we'll save it. Alright, now if you click on it, you can see we have the target application, fault is there, and probe is also there. Cool. So all the changes that you made using the UI, you can also see them in the YAML as well. So if you go, let's say here, you can see that your app info is here, the app name is boutique, label is front end. Then you can see your fault configurations and everything. So everything is in this YAML, and you can also edit it from here, which will reflect on the UI as well. Let's go to the visual, and let's run the experiment. So it has started running the experiment, and it will perform 3 steps. First is it will install the chaos, then it will perform the chaos, and then it will clean up the resources. So it has started installing the faults. So let's go to the terminal to check. Let me clear this out, and if I do kubectl get pods litmus, you can see there is one job running, that is FE kill. So it has started installing chaos in the namespace. Let me check it again. You can see FE kill is up and running, and pod delete has started running. Let me try seeing the pods again. Okay, jobs are running, and I'll keep refreshing the browser in order to see if the chaos has been successful or not. I can see the URL is not loading right now. That means the service might be down for now. And if I go to terminal again and clear everything, kubectl get pods boutique. Okay, and you can see that this has been just restarted. That means the pod kill has been successful. As you can see, the pod delete has been completed, and the probe has been failed. This is because and the pod was deleted, the front end service was completely down and we were not able to access the front end. So if I go to the pod delete, and if you see the probe, you can see the probe check has been failed, and this is because we didn't got 200 response code during the entire experiment. That means the system is not resilient at all. So this is how you can create your own hypothesis on different set of scenarios that you want to create in order to perform the chaos engineering on your system, in order to test how resilient it is on different type of disasters that may happen due to traffic, due to network loss, and many more other scenarios.